All right, thank you all for coming. My name is Micah Yoder. I am a Linux engineer at Rackspace Hosting. I work on an internal tools team where we deal with logging and monitoring and some other kind of stuff like that. Now, I have been using PostgreSQL off and on since probably the late 90s. I'm interested in all things open source databases, and I also dabble with other databases like MongoDB, and I want to play with a lot of the others also. Now, there's been a trend in open source databases where the more relational databases, well, you have the NoSQL movement, of course, which I'm sure you're familiar with, but the traditional open source relational databases are starting to pick up some of the features of those things. Now, I guess I should go backwards a little bit. PostgreSQL has a long history of innovating and putting in more data types than most of its competitors. Like in traditional SQL fields, normally you can just store an integer or a Boolean or a string or whatever. But PostgreSQL has long supported arrays, it's long supported geometric types, network types, and other complex aggregate types. And as of a few years ago, it started supporting HStore, which is a basic key value store. And as of version 9.2, I think, it added a JSON type. And that can store basically blobs of JSON as text. And it validated the JSON, but it didn't really make it efficient in the back end or anything like that. So that now in 9.4 it adds JSonb, which is kind of like the JSON type, except it's binary JSON. It stores it in the back end in an efficient way that it can process efficiently on the server side. Now MySQL kind of does, well, actually the MariaDB fork of MySQL kind of takes on another form of NoSQL. If you're familiar with Cassandra, the column store database, well, MariaDB 10 adds something kind of like that. So you can see that the traditional relational databases are kind of picking up on the NoSQL movement as much as they can. But here we're going to focus on PostgreSQL 9.4 and JSonb. Now, I'm sure you know what JSON is. There's an example of it. It's basically an arbitrary structured document. So you can put in any kind of data you want in any kind of structure. And as I said, JSonb is binary JSON. So all this is stored efficiently server-side. Now, why would you want to do this? My thinking was that, and you can imagine a shopping cart application where you have a large table full of all kinds of products that are for sale. Well, you're going to have some attributes that are pretty basic and pretty common to all products. You're going to have the product ID or SKU, the title of the product, the date added to the catalog, the price, the status, whether it's available or not, and a basic description. So you'd probably want to store these in basic normal SQL fields like integers or strings or whatever for maximum performance. Yeah. Okay. Now, there might be other things, other attributes that might impact some products that are fairly sparse. You would not assign them, you would not put them with every product. So maybe if a product has a more detailed specification list, you could store that in a JSonb field, or a more description text, or if it's food, you could store nutritional information that way, or maybe customization options, or a list of photos with their attributes, or any kind of other special notes, or geographical information, or whatever. Just anything that might be relatively sparse and not something you'd associate with every single product. And I think that would be more efficiently stored in a JSonb field called additional information or something like that. So here are 3 ways to do it. Say you're just using normal SQL fields. Well, you're probably going to have more than one query to fetch all the data. First, you're going to have to fetch all the basic fields from the products table. Then if it has photos or specifications or nutritional information or anything like that, you're going to have to go back to the database again and run another query and go get that information separately. And if you have several of those, that can add several round trips to the database, and that could slow down your page load time for your customers. And that might be especially true if you have some joins. And of course, JSON documents can alleviate the need for some kinds of joins. Now, MongoDB does this. Of course, MongoDB is a pure JSON document store. And so you can store everything in a JSON document, including all the fields that I mentioned back here, like the SKU and the title and everything. Those would all be in JSON fields in MongoDB. And the advantage is you can fetch everything with a single query to MongoDB. The disadvantage is, I think, that when you store every single field in every single row, you also have to store the name of the field in every row, and I think that's potentially a little bit wasteful. Now, in PostgreSQL with jsonb, it's also like MongoDB. You can execute one query to fetch the whole thing. So you'll fetch the standard SQL fields like the title and the SKU and all that, along with the additional info in jsonb. And it's only one round trip to the database, and so it's extremely efficient. And I'll show a little more about how to process that later, but first I want to talk about indexes a little bit. So there are two possibilities for indexes in a JSONB document. First, you can have a GIN index. Sorry, this is wider than the block. So you can specify a GIN index on the whole JSONB field, and then you can run a query like this that will use the index. That will basically check, I'll talk about operators later, but this basically checks that this JSONB document is contained within the database field, and that will use the index. Now you can also create an expression index on any kind of expression in Postgres, and here we're doing that. Rats. So here we're creating an expression index on a single key in a JSONB document. So you'll see to query the document using this index, you'll have to use an expression in the where clause that's very much like the expression you used to create the index. However, I might note that if you're going to need to put an index on something, in general, it might be better to just put it in a normal SQL field as opposed to a JSONB field. There might be exceptions, but it's probably how I would do it in most cases. So here's an example of using it from Python. It is supported by the normal CyclePG2 library, which is the most common PostgreSQL library in Python. JSONB is officially supported in version 2.5.4, which was released, I think, a couple weeks ago. I actually was able to get this to work in 2.5.3 also. I think the main advantage is an internal efficiency advantage of how it connects directly to the type without an additional conversion layer. But it's pretty straightforward. You just import the CyclePG2 module and also the extras module, which has the JSON type that deals with this. So you have your standard connection string to the database. Then you start building your data. And it's a standard Python dictionary. You can put anything you want in it, including arrays, whatever. This will all map to the JSON fields. Then you get a cursor, and you use the cursor to execute the insert query. And so you can see how it's put in there. But CyclePG2 has the execute function, which takes the JSON field or the JSON data type, which you put your dictionary in, and that automatically puts it in the insert statement in the proper way. Here's an example of querying it from Python. So basically, you just run your select, you get your result and split it into the ID and JSON fields, and then you can treat the J field, which is the JSON, just as any Python dictionary, just like you put it in as. So here's how I might propose using it in my hypothetical products table. You're going to select all your fields from the products table in one query. then if, this is an extremely efficient check, you can efficiently check if nutrition is in the additional info field, and if so, print out the nutritional information. If the specifications are in the field, go ahead and print them out, and etc. Those are all extremely fast checks, and I think this runs extremely efficiently. Performance. Now, there are a few things to be said about here. I tried inserting a million small JSON documents in both Postgres and MongoDB. Now, the top line, no full commit. With MongoDB, I use the default write concern, which does not wait for it to write to the, does not wait for an fsync to the disk. It just shoves it out there and hopes it succeeds. And in Postgres, I did everything in a single transaction, and this is the timing I got. So you can see Postgres appears to be a little bit faster. Now, the full commit line, frankly, I don't believe this, and but basically, for Postgres, I used every document in its own transaction, so a million small transactions. And in MongoDB, I set write concern j equals true, which does wait for an fsync to the disk, and it tells the application it succeeded in durably writing it to the disk before continuing. And I'm not quite sure why the number is so high on MongoDB. The CPU load and IO weight were both low, so I am not an expert database benchmarker. So maybe someone who is should look at that sometime. But
if you're waiting for a full fsync, that's not that for a million documents. That's not unexpected.
Yeah. Well, yeah, Postgres.
A million 1K documents. 1K.
Actually, I think they were about 60 bytes. So.
Okay, so but that's still going to cause a 4K byte, right?
Yeah. Okay.
Okay, so and that's going to cause a full sync and dump of all the cache. It's expensive.
Yeah. Yeah, I just wonder why Postgres was so much faster, but. I also did a similar thing on a remote cloud server, and they were a lot closer in performance, but of course the network latency would have had something to do with that. Query performance. I didn't do any formal timing, but I did do table scans of both of them. They both returned in under a second, and I could not perceive any real difference between the two. Of course, they were both within the page cache in RAM. Now, query operations and indexes and operators. So there are a few operators. I already mentioned the at greater than operator. That basically returns true if the JSONB document on the right is contained within the JSONB document on the left. So you can use that to search through a table for a specified set of keys and values. On the second row, we have, let's see, I don't know how you'd pronounce that, but basically these two operators can check if a certain index or a certain key is within the JSONB document, and then, well they actually return the field as JSONB. And under that, yeah, you can select by either a string key or a numerical index if the root of the JSONB is an array. So under that, you can also, the operator with two dashes, or no, two greater than signs instead of just one, does the same thing, but it returns them as text. So you can do text string functions on the result. And then you can also do a look in the document within a certain JSON path. You can use a comma-separated list of strings for subkeys or numbers, which would be indexes into an array. So you can go arbitrarily deep that way. Now, how does it compare to MongoDB? Well, from what I can tell, it is not possible to do something like this within a JSON document. In MongoDB, it lets you query the documents based on, if in this case is if number is less than 5. So MongoDB has a pretty elaborate query language where you can construct basically a JSON document that describes the query, and of course it has pretty much everything you can do with an SQL field within any of MongoDB's JSON fields. And it's pretty elaborate, so any kind of comparison, whether it's in a set, anything like that. Now, yeah, like I said, as far as I can tell, there's no way to do that within JSONB. Also, comparing how you do updates in both of them. Again, MongoDB has this query language where you can update a large number of rows in a certain way. Well, there's this update query that it queries which rows will be updated. Then it has this update query that will specify how to change the documents. And then the multi-true tells it to do more than one row at a time. So with this, you can do as many rows as you want in one single round trip to the server, but it's not atomic. So it's possible that the server will crash or something else will go wrong, and some of the fields might be or some of the rows might be updated and some will not be updated. Now, Postgres, from what I can tell, also does not allow you to do that directly. But what you can do is start a transaction and do a select for update, all those fields from all those rows, and then you'd have to pull them down into a Python dictionary and make the required modifications there, and then send them back up with an update statement, and then commit the transaction. So that's a little more powerful maybe, but it is atomic. So either it will all succeed or it will all fail. Also, I would say that doing it in Postgres, working with Python dictionaries in Postgres is a lot easier than MongoDB's update language, which requires you to construct basically a little JSON document describing the update. And frankly, I think that's a little bit tedious. But on the other hand, you have to pull each record down over the network, load it into your Python, and send the update back up. So if it's a large document or if you have network latency or anything like that, that could be a disadvantage. In storage, I found that Postgres' JSonb was just a little bit larger than what I got in MongoDB. I had actually read a lot of reports that JSonb took an extraordinary large amount of storage, but I was not able to reproduce that at this time. It seems to be okay for me. So, and I think that's about it. So I was wondering if there were any questions or.
So is JSON being intended to be an interchange format at all, or is it exclusively an internal to Postgres implementation detail?
I believe it's an internal to Postgres detail. I don't think you can get it out of the database in any other way than through Postgres. Oh. Any other questions?
Yes. Do you use static anchor for anything at this point, or is it something you just looked at?
I've pretty much just played with it. Yeah. It's still. Oh, I think I forgot to mention that Postgres 9.4 isn't even in production yet. It's in a beta 2, and I believe it should be released any day now. Yeah. All right. Anything else? All right, thank you.